All right, let's talk about the story of electricity. But we gotta forget that simple little tale of a light bulb flashing on. The real story, the one that actually matters, isn't about one invention. Nope, it's about a completely new way of thinking, a system that literally built the world we live in today.
So let me ask you this. How do you actually build the future? We have this picture in our heads of innovation being the single aha moment, right? But what if the real story, the one behind every single world-changing technology, is just so much bigger and way more connected than that? Because here's the thing, to really truly change the world, you can't just make a tiny improvement to what's already there. You don't get the electric light by just building a slightly better candle. You have to be willing to throw out the whole concept and rethink the entire system from scratch.
And that's exactly what the pioneers of electricity did. They didn't just invent a cool new gadget. They invented a brand new way to think. And this was the great mental shift, moving from focusing on a single, isolated device to designing an entire integrated system.
Okay, so the first crucial leap was seeing beyond the object itself. The old way of thinking? Just build one perfect device. But the new, totally revolutionary idea was to design the entire network that this device needed to even exist. We're talking power generation, distribution, the whole shebang.
And this right here just shows you the insane scale of what they were up against. This wasn't like swapping a steam engine for an electric motor in a factory. No way. This meant building the entire infrastructure of the modern world from nothing. So, who were these masterminds, these people who pulled off this shift? Well, they weren't just inventors tinkering away in a dusty workshop. They were system architects, and they were literally drawing up the blueprint for a new civilization.
Now this is where it gets really interesting, and kind of backwards. Edison's approach was completely counterintuitive. He figured out that to make his whole system cheaper and actually work on a citywide scale, a key component, the filament, had to be worse at its job.
See, everyone else at the time was obsessed with finding a low-resistance filament. But Edison? He realized that a high-resistance filament would let him use way thinner and therefore dramatically cheaper copper wires to power everything. He made one part less efficient to make the entire system affordable.
But there was a huge problem with Edison's direct current system. It just couldn't travel very far without losing a ton of power. And this is where Nikola Tesla and George Westinghouse entered the picture. Their solution? Alternating current. Thanks to a little device called the transformer, AC could send power over hundreds of miles, which suddenly made massive, centralized power plants possible.
And Tesla's AC induction motor. Oh man, that was the final killer piece of the puzzle. It was so simple, incredibly reliable, and super powerful. It was the engine that was going to go on to revolutionize manufacturing and basically power the entire 20th century.
Okay, so you've got these incredible ideas, these amazing mental models, but how do you actually turn all of that into the physical grid that's lighting up our lives right now?
Edison's real genius wasn't just his ideas, but his execution. He created the world's very first industrial R&D lab at Menlo Park. It was a place specifically designed to invent, test, and perfect every single part of the electrical system all at the same time.
Think of it like a playbook. He was patenting everything at once. The filament, the socket it screws into, the generators to make the power, the plan to distribute it, and even the meter to bill you for it. He built the entire ecosystem simultaneously, making sure every single piece worked together perfectly.
And this comprehensive approach, well, people noticed. His attention to the complete system was so radical that it was immediately recognized by industry leaders all over the world. They saw it for what it was, a total masterpiece of design.
But look, great tech is one thing. For electricity to really take over, it had to be cheap. And cheap meant it had to be scalable. This is where the AC system really had the advantage.
The transformer was the magic ingredient here. Seriously, this pretty simple device let you step up the voltage to incredibly high levels, which meant you could send it a long way with very little energy loss, and then step it down to safe levels right before it entered your home. It's what made the AC system economically unbeatable.
Of course, none of this happens without cash. A technological system is also a business system. You have to have strategic financial backing and really clever business models to make something on this scale actually happen.
And then you get the ultimate power move. One of the most powerful financiers in the world, J.P. Morgan, lights up his entire mansion with Edison's system. That move sent a crystal clear signal to everyone. Electric light wasn't just a toy, it was the future. It was a symbol of status and progress.
But the business innovation didn't stop there. Leaders like Samuel Insull focused on this brilliant idea called the load factor. Basically, it was about making sure those super expensive power plants were being used as much as possible. By selling cheaper electricity to factories during off-peak hours, like at night, they kept the generators running 24/7. That move dramatically lowered costs for everybody and made the whole enterprise way more profitable.
So after all this, what's the big takeaway? What's the timeless lesson here for anyone out there trying to build the future today?
Well, the history of electricity really gives us a blueprint, doesn't it? It shows us that true, world-changing innovation, it doesn't start with a device. It starts with a whole new way of seeing the problem. It means you have to design the entire system, build the industrial muscle to make it real, and have the commercial strategy to fund the whole thing.
You know, when you think about it, the electric grid was basically the internet of its day, a massive network for energy and information. And it just leaves you with this one big question. What's the next fundamental system that we are on the verge of building right now? That's all for this explainer.